lot of this first information is duplicated from yesterday, so I'm gonna go through it pretty quickly. So a sequence would be your set of numbers in a particular pattern or order. The pattern today is gonna be multiplying. Now if you notice that it looks like dividing, that is technically multiplying by a fraction. So dividing by 2 is the same thing as times 1/2. So approach it as multiplying. Okay. So each number in a sequence is called a term. First term is the A1, second term would be A2, and so on. A finite sequence contains a limited number of terms, while an infinite sequence continues without end, so it does not end. We'll deal more with that in what we're doing tomorrow. And then sequences can be defined as functions. We're not going to be graphing anything, but they can technically be graphed. Geometric, since it's multiplying, that would look like an exponential graph. It would curve. Versus arithmetic would be a linear. We're not going to graph them, but that is how they're related with what we've been doing. In a geometric sequence, each term is determined by multiplying a non-zero constant by the previous term instead of adding or subtracting from yesterday. The constant value is called the common ratio. That is denoted by the letter R. Yesterday, common difference was D. Common ratio is R. So it's whatever is being multiplied each time. Okay, so that's the only letter change from yesterday to today. The explicit formula. So this is defined the nth term, whatever term you would need. We're going to use this several times today. So make sure that you have that. On your quiz on Monday, I will provide all the formulas, but you need to know what to use when, what the letters mean, all that. Okay. So the formula would be A sub n equals the first term A1 times R raised to the power of n minus 1. And n is whatever numbered term it is. Okay, so that'd be the little sub number on there. So that is the explicit formula. That will show any term, okay, as long as you know the first one and how it is being multiplied by each time. The recursive formula, that's what we did at the end yesterday with arithmetic. So those ones, it's a little bit longer of a notation, but you have to know the term before it to find the next one. We're going to go back and forth between the two today. So that would be right here. So it's R times A sub n minus 1. Yesterday it was plus D instead of that. But you had a couple of those in your homework yesterday, so it might look a little familiar. All right. So we'll come back to that information. We're going to start off with how we started off yesterday, determine whether it's geometric or not. That is if it's multiplying by the same number each time. And how do you get from 2 to 6 by multiplying? Times 3 is 6 times 3, 15. No. Okay, so as soon as that is off, the answer would be not geometric. What you also could do is do the second number over the first and divide it. So that would be 3. If you did 15 over 6, that would be 2.5. So as soon as that does not match, the answer is not geometric. Okay. So given the fact that these next ones are bigger numbers, for those of you that aren't great at multiplying in your head with bigger numbers, if you do the second number divided by the first number, the third number divided by the second number, and the fourth divided by the third number, all of these, if they come out the same, it is geometric. So this is another way you can approach it if you don't know multiplication off the top of your head, especially if they're big numbers. So what's 48 divided by 16? This is why you have a calculator. 3, what's 144 divided by 48? And 432 divided by 144? 3. Okay. They all have to match in order for that to be geometric. So since they do, yes, this is geometric. As soon as they don't, so I didn't do the third one on the first example, as soon as they don't match, it's not geometric, but it has to be by multiplying. Yesterday I had to do that. So questions on determining whether it's geometric or not, because you got a couple of those in your homework. All right, equation for the nth term. Now this is the explicit one. It's the first one I boxed up there. So the nth term, so it's basically not the recursive one. So it's A1 times R to the power of n minus 1. You are writing that formula. Okay? We're not finding a certain numbered term. That's for any term. So you need A1 and you need R. So on C, what's the first number? -1. Okay, so right there, that's A1. So we're pretty straightforward. How are those being multiplied each time? -3. That is the R value. So the common ratio, you could do 3 divided by -1, -9 divided by 3, and 27 divided by -9. All of them are -3, and the negative is important. So R is -3, A1 is -1. Again, the -3 is times each time. There we go. If it's changing signs, it has to be a negative, so just be aware of that. Any questions so far? That's the only information you need to write these explicit formulas. So that would be A sub n equals our first term, -1. If you have a negative sign, definitely use parentheses, but I'll use them either way, times -3 to the power of n minus 1. So you would use this, if I said I want to know what the 100th term would be, you would plug 100 in for n and simplify. Okay, so this is what that formula is used for. Okay. So all you need for that is the R value and the first term. Okay. Now on problem D, we're obviously not given the first term, but you are given R. Okay. So this one, we're going to have to do some manipulation of this explicit formula. Okay. So we're going to use this term to figure out what A1 is. So we don't know that value, but you need it to write that function. Okay. So we're going to have to use our algebra skills to do that. We do have R. Okay. Now we're going to use the 8th term, which is 5, to isolate A1. So the 8th term of 5 is going to go where A sub n is, right here. Okay. So the whole 5 is going to be there. N is what numbered term it is, which is the 8. Okay, so those will go together. So we're going to plug that in. So the 8th term is 5. We don't know our first term. Our R value is 1/2. And the 5 is the 8th term. So that's going to go where that is. So N is 8. It's whatever number term that is. Okay. So it's the sub number. So the A8. N is 8. So we're using this to figure out what the first term is so that we can write the formula. I would start off by finding what 1/2 to the 7th power is. Okay. Now in your calculator, again, if you have a fraction, put it in parentheses as a division problem. So 1 divided by 2 raised to the power of 8 minus 1, which is 7. Now you're going to get a decimal. I don't want you to round anything, so change it back to a fraction. How do we do that?
I think go to fraction.
We hit math. Okay. Fraction. So 1/128. Okay. Or you can figure out what 2 to the 7th power is and just put that on the bottom, which is 128. Okay. So we still have 5. And that's equal to A1 times 1/128. So we simplified this part here. Now how do you get A1 by itself? Well, you're dividing by a fraction. And how do you divide by fractions? Multiply by the reciprocal. So if you multiply by the denominator, 128 on both sides, that'll get rid of it over here. What is 128 times 5? 640. So now you have A1 and we have R, so you can write this formula, okay, for any term. We just use the 8th term to get there. So now we go back to this formula. So A sub n equals my A1 term of 640 times my R term of 1/2 to the power of n minus 1. So sometimes you'll have to manipulate it to find A1 or R sometimes. Okay. But that's really as tough as they get. Okay. So sometimes you might have to solve for A1 if it's not given to you. Okay. But keep in mind, this number and this number go together. Because it's the A sub n. Questions before we go on the back side? Okay. Now on the back side, given a formula for a geometric sequence in either recursive or explicit form, you're going to translate it into the other. So you're going to go from one form into the other. So is E currently in explicit, which is what we just did, or recursive? Recursive. Okay, that's the longer one. So we're going to change this to the ones we were just doing. So we're going from recursive to explicit, which is this. So we need A1 and we need R. Okay, what's A1? It's right there. A1 equals 5. Okay, so 5 will go there. What's R? R will be in the equation portion of it. So up here, that box right here, it is R times the A sub n minus 1. So within the recursive formula, R is just floating out front, being multiplied by the A. So on this one, R would be what? 1/5. Okay. So R will be within the recursive formula, just in front of the A. Okay. So 5 times our R value of that 1/2, 1/5, power of n minus 1. So that is this formula from recursive to explicit. As long as you can figure out what R is and what A1 is, that's the only information you need to write either one. Okay. So the one that we have over here is in explicit form. You would still need the same two pieces of information. Which number is A1? It's the one without the exponent, so it's floating out front here, so 2/3, which would mean R is the one with the exponent, which is 7. Okay. Now explicit's going to look like this over here. Okay. So we do the A1 term. So A1 is 2/3. Now A sub n equals R, which is 7, times A sub n minus 1. That's always there. It's just R times whatever term it is. And then, we talked about that yesterday. It's just the limit on the domain, and it has to be at least 2. Because you would use it on the next term. So that is the recursive form of that explicit. You'll have a couple of these in your homework also. As long as you can figure out what A1 is and what R is and where they go in the other form, you should be okay. But we got to practice with both forms. Am I going too fast for anybody? Okay. So everyone's good so far? Now we're going to use geometric forms to answer this last one. It's going to require a little bit more work, but it's kind of similar to problem D on the front where we had to manipulate that one form. Now, what's a mean?
The average.
Now, an arithmetic mean, which we did arithmetic sequences, arithmetic mean is the average. A geometric mean is not. Okay, so that is different between the two. Now, you'll have a couple of these in your homework as well. So find 4 geometric means between 243 and 32. What that is telling you is that 243 is first in this sequence. There are 4 numbers between that number and 32. So we have 1, 2, 3, 4, and then 32 is the last term in that sequence. It's asking you to figure out what 4 numbers go in between the two. Okay. So that's what a geometric mean is asking. Questions as of right now? Now it might tell you 3 terms in between, but if it says 4 geometric means, it means there's 4 terms in between. So 243, that's the first term. What term is 32? So 1, 2, 3, 4, 5, 6. So this is the 6th term. We do not know what R is. Now, similarly to how we solved for A1 on problem D, where we manipulated that one formula, so the explicit formula is what we're going to use. But this time we don't know R. We do know A1. Okay. So N is going to be 6. We're going to use the 6th term on the AN part, and then A1 will go in there. So we're gonna use this just differently. We're solving for r this time. Instead of 8. So the nth term, which is the sixth term, is 32. The first term is 243. We don't know r, so that is raised to the power of 6 minus 1. Again, this number and this term should be together. So the sixth term was 32. Okay, so those two should go together. So we're trying to solve for what r is, which means we need to isolate it. So how do we do that? Goal is to get r by itself. Divide by 243. Now in our calculator, so that will get r by itself over here. 32 divided by 243, not a whole number. If you turn it back into a fraction, so hit math fraction, it puts it back into 32 over 243. That means it's as reduced as it can get. So we're gonna leave it, but you can always check that. So we have 32 over 243 equals r to the fifth power. So 6 minus 1 would be 5. So how do we figure out just r? What's the opposite of the fifth power? Fifth root. Okay. We're going to take the fifth root, just like the opposite of a square is a square root. We're going to take the fifth root of each side. And you can do it with a fraction. It's just the fifth root of the numerator over the fifth root of the denominator. We can do the whole thing in the calculator. Now, in case you don't remember how to do a specific root, type the number of root in first. So I'm doing fifth root, so I'm going to hit 5 first. Go to math, and then it's option 5 where it has a little x radical. Okay. If you have a newer calculator, it will put it up there. If you don't, it will just have it out front. It knows. So the fifth root of 32 divided by 243. If you have an older calculator, close off the parentheses that are there. It will give you a decimal, turn it back into a fraction, which would be 2/3. Or the fifth root of 32 is 2, and the fifth root of 243 is 3. So you can do them separately if you want to do that too. So 2/3 equals r. Is that what you're being asked for? No, but it's going to help you figure out what you're being asked for. Okay. R is what's being multiplied by each number to get these ones in between. So your first step from this point would be to multiply 243 times 2/3. That times 2/3, and so on. Okay. So in our calculator, 243. Now you could do times 2 divided by 3 like that, and it knows to multiply first, and then it'll divide itself by 3. Okay. So that would be 162. That is your first geometric mean. Times 2/3, 108. And 2 more times. Times 2 divided by 3, 72. And times 2/3, 48. So when you're asked for these 4 numbers in that order are your answer. What we figured out are to figure those out. So ones like this one and then ones like example D, those are as hard as they get today. So hopefully if you took good notes, you should be okay on those. But majority of them are very straightforward like the rest of them. Make sure you copy down the original problem, even if it's just like example A or C or whatever. Copy down the list of numbers, show work, answer it, okay, depending on what it's being asked. All right, you have around 15 problems. Get started.